This is my intermediate algebra course. Today we're going to prepare for the third test of the course. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I mentioned in previous classes, there are some subjects where you can study an hour the night before and get a really good grade on a test. But math doesn't work that way. With math, you need at least 2 days to prepare for a test. And really, if you want to get a good score, you need 3 or 4 days minimum. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to take a practice test right now together, and I'm going to give you a practice test for homework. And these tests are not only going to force you to do at least some studying, but they're going to familiarize you with the format of the test so that you can't say that you were caught off guard. The actual test is going to be very similar to these practice tests. Now, you will need a calculator on this test. You're not allowed to use the internet or any kind of program that will solve the problem for you, of course. You have to show work. The only reason that you are allowed a calculator is to do the necessary operations in the last step, or the calculations in the last step, so that you can approximate some of your answers. But you are allowed a calculator, and it's best for you to use your graphing calculator so that you can get familiar with that calculator. If you don't have your graphing calculator, then your iPhone or a scientific calculator will work, but be aware that some calculators are too simple for the type of math that we're going to be doing. Now, you don't have to write the Roman numeral of the exponent rule or logarithm rule that you use for various problems. We only did that in previous parts of the course to show you, what rules we were using, but at this point you don't have to do that. Also, be aware that you're not allowed to leave your answers with fraction exponents, negative exponents, zero power exponents, or first power exponents. You need to convert to roots, to fractions. You're not allowed to have those strange exponents in your final answer. Now, I don't care how long it takes you to finish the test. It may take you an hour or 5 hours. The most important thing is that you can do it on your own without any help. Of course, I'm talking about the actual test. You can use whatever resources you need to finish these practice tests, but I'm just telling you that time is not really the most important thing. The most important thing is that when you take that test in the next class, you can do it from your own memory. And there are 25 problems, 4 points each, for a total of 100 points, like all my tests. And so I think that's about it. Now, as in the previous practice tests that we've done in the first and second part of the course, I want you to attempt these problems on your own. So see if you can do this problem. Don't just watch me do it. Attempt every one of these problems before watching me do them, and that's going to give you a lot more useful information regarding your readiness for the test. And if you get stuck, that's okay. That's completely fine. But attempt the problem, and when you come back, we'll do it together. Okay, we're back. So anything raised to the 0 power is just 1. So that was kind of a trick problem. We had this very complicated looking base, but it doesn't really matter how complicated it looks. If you raise it to the 0 power, it's just going to be 1. Now, there are some bases where if you raise to the 0 power, it may not have any meaning, but you're not going to see that really in the math curriculum, so you don't have to worry about that. Okay, for example, 0 to the 0 power, that really doesn't have any meaning, but you don't have to worry about those cases. So we used exponent rule 7. That was exponent rule 7. You don't have to write that, but I'm going to tell you the rules that we're using. the properties, whatever you want to call them. Go ahead and attempt number 2. Again, if you get stuck, that's okay, but try number 2, and when you come back, we'll do it together. Okay, we're back, so we need to use exponent rule number 8. Negative exponents don't have any direct meaning. We have to translate, and what that means is 1 over 1,000 to the positive 1/3 power. Again, we have to translate it. Now we're closer to figuring out what this value actually is. But now we need to use exponent rule number 9, which tells us that 1/3 power is the same thing as the cube root of 1,000. So up here we had no idea what was happening with this expression, but now we see what it means. And the cube root of 1,000, well, just ask yourself what number times itself and then times itself again is equal to 1,000. And if you do some trial and error, you'll find that it's 10. So our final answer is 1 over 10. So if you got that, good job. All right, try number 3. And when you come back, we'll do it together. Okay, we're back. So I'm going to use exponent rule number 1 to get 16 to the 5th power. Exponent rule number 1 says to add the exponents. And we can only do that because we have the same base. They're both base 16. At this point, we don't want to raise 16 to the 5th power because that would be really difficult. It'd be a large number. So we want to use the variation of rule 10. And we're going to change the form of that. Remember, rule 10 tells you that you can put this 5 inside the root or you can put it outside the root. It's the same, going to give you the same value. So now we can calculate the 4th root of 16. What number times itself and then times itself again and times itself again is equal to 16? And again, trial and error will tell you that that is 2. So we have 2 to the 5th power. And that's kind of a big number, but it's manageable. That's just going to be 32. So if you got that answer, good job. So we used rule number 1, exponent rule number 1, and then exponent rule 10, the variation of that. Go ahead and try number 4, and when you come back, we'll do it together. Okay, we're back. So we are going to use the variation of rule number 8. That tells you that when you have a negative exponent in the denominator of a fraction, you can bring it up and turn the exponent to a positive number, convert it to a positive. When you have negative exponents in the numerator, you can bring them down, they become positive. When you have negative exponents in the denominator, you can bring them up and make them positive. And the same is true if you start with positive exponents. If you have a positive exponent in the numerator, you can make it negative by going to the denominator. If you have a positive exponent in the denominator, you can make the expression go up into the numerator by changing it to a negative exponent. So as you get more and more experience with this stuff, you'll become more comfortable doing that. So now we're going to use exponent rule number 10, which tells us that that means the following. But notice I wrote the 2 there in the index, but when you have a square root symbol, you don't have to write the 2, so I want to get rid of that. Now, remember, we can use the variation of rule 10, which tells us that we can put the 5 on the outside. And then we know that the square root of 9 is 3, and that's kind of a big number, but if you use we know 3 times 3 times 3 times 3 times 3, that's 9 times 9 times 3. So 9 times 9 is 81. 81 times 3 is 243. So our final answer is 243. So we use the variation of Rule 10 here. We didn't want to raise 9 to the 5th power. That's why we did that. You see, that would be very difficult. All right, if you got that answer, good job. If you're having trouble with any of these, that's okay. That's the point of this practice test, is to give you an idea of what you need to study and what you may not need to study quite as much. And it's this is going to warm up your brain if you haven't been going over this stuff in the last couple days or week or so. Okay, try number 5. When you come back, we'll do it together. All right, we're back. So we could use exponent rule number 2 to combine these, or we could use the same rule to combine these, exponent rule 2. But I prefer to use exponent rule number 1 in the numerator first. That's just my preference. And also, we need exponent rule 6 to convert this to x to the first power. So x to the first power times x to the second power is x to the third power. So I added those exponents. And now we're going to use exponent rule 2, which means that when we're dividing powers, we subtract the exponents. So we get x to the negative 1 raised to the negative 3 power. And then we're going to use exponent rule 5. When we're raising a power to another power, we multiply the exponents. So negative 1 times negative 3 is 3, and that is the final answer. So if you got that, good job. Again, we used exponent rule number 1, exponent rule number 2, and exponent rule number 5. Try number 6, and when you come back, we'll do it together. Okay, we're back. We're going to use exponent rule number 4, which tells us that when you raise some fraction to some power, that's equal to the numerator raised to that same power divided by the denominator raised to that same power. All right, so now we're going to use exponent rule 5 because we're raising a power to another power up here. So 3 times 1/3 is 1. And we're doing the same thing here. 3 times 2/3 is 2. Because the 3's just cancel out when you multiply those. So, and for the last step here, we could take that first power and change it into x. That's exponent rule number 6. So we have x over y squared. That's the final answer. So if you got that answer, good job. Okay, number 7. Go ahead and try number 7. And when you come back, we'll do it together. All right, we're back. So we're going to use logarithm property 5. And that tells us that we can separate the product. There's 3 terms in the product. So we're going to separate into 3 different logarithms. And then we're going to, we can't do anything with the first logarithm, but we're going to take this yellow 2 power and throw it in front. That's logarithm property 7. We're going to do the same thing with the other logarithm. Throw the 4 in front. Okay, so that is the final answer. These are multiples of logarithms because you have 2 and 4 multiplied into the logarithms. Okay, if you got that right, good job. On to number 8. Now we're going to solve equations. So see if you can solve that equation. And when you come back, we'll do it together. All right, we're back. So I'm going to use exponent rule number 6 to change 7 to 7 to the first power. And now we have exponential expressions that are equal to each other and the bases are the same. So that means that the exponents must be the same also, because the equation tells us that these expressions are equal to each other. So I took this exponent and wrote it there, and I took this exponent and wrote it there. So if we solve, we end up with x is equal to 4. So if you got that right, excellent. Try number 9, and when you come back, we'll do it together. Okay, we're back. We can't solve this unless we change the bases so that they're all the same. So what I'm going to do is change 9 to 3 squared, and I'm going to change 27 to 3 to the third power, or 3 cubed, however you want to say that. And now I'm going to use exponent rule 5. When you're raising powers to other powers, you multiply the exponents. 2 times 2x is 4x. And 3 times x plus 1 is 3x plus 3. Now we have exponential expressions that are equal to each other and the bases are the same, so that means that the exponents must be the same also. Subtract x from both sides and we get x is equal to 3. So if you got that one right, good job. Okay, try number 10, and when you come back, we'll do it together. All right, we're back. So this is a logarithmic equation, and it's a very simple equation because the logarithm is already isolated. It's already by itself on one side of the equation. So remember, the most important thing when it comes to logarithms is learning how to translate back and forth between the exponential form of an equation and the logarithmic form of the equation. The base of the exponential expression is always that little number there. And the exponent is always what the logarithm is equal to. And what goes on the other side is always what's inside the log function. So all we did was just translate from logarithmic to exponential. But remember, we're not allowed to leave our answer with a negative exponent, so we have to use exponent rule number 8. 3 to the negative 2 power is 1 over 3 to the positive 2 power, and 3 squared is 9. So there you go. Have you got that one right? Excellent. Okay, on to number 11. See what you can do on number 11, and when you come back, we'll do it together. Okay, we're back. So let's set x equal to log base 6 of 36. And in order to figure out what this is asking us, we need to translate this into an exponential equation. But again, that's why we had to write x equal to, because we didn't really even have an equation. So the base is always that small number. The exponent is always what the logarithm is equal to. And whatever's inside the log function, that always goes on the other side of the equation. So we've converted from a logarithmic equation to an exponential equation. And by doing that, we can now see what what x is. X is what we're looking for. That's the value of log base 6 of 36. So let's change 36 to 6 to the second power, and we can see that because these expressions are equal and they have the same base, the exponents must be equal also. So if you got that one right, good. Okay, try number 12, and when you come back, we'll do it together. All right, we're back. So we can't do this problem. It's too complicated. Unless we change the expressions so they have the same base. I'm going to change 8 to 2 to the third power. And I'm going to change 4 to 2 to the second power. And I'm going to use exponent rule 9 to change cube root 2 to 2 to the 1/3 power. And I'm going to change 2 to 2 to the first power. That's exponent rule number 6. So now I'm going to use exponent rule number 2 and subtract these. So 1/3 minus 1 is negative 2/3. And I'm going to use exponent rule 5 on both of these, so I get 2 to the 3x, 2 to the 2x. Exponent rule number 5 tells us to multiply the exponents if you're raising a power to another power. Now I'm going to use exponent rule number 2 again. And I'm going to subtract 2x from 3x to get x. So again, 3x minus 2x is x. And the only reason that we can do this is because we have the same base. So now we can see that this equation is pretty simple at this point. The bases are the same, and the expressions are equal to each other, so that means that the exponents must be equal to each other also. So there you go. Okay, if you got that one right, excellent. That was a more difficult problem. Try number 13. That's going to be an even more challenging problem for a lot of students. If you get stuck on number 13, that's okay. But that's one of the types of problems that you will need to be able to do on the test. Try number 13. When you come back, we'll do it together. All right, we're back. So I'm going to change the form of this equation. I'm going to change it to 5 to the x power, all raised to the second power, and just rewrite the other stuff in the equation. Now the reason I could do that is exponent rule number 5. You see, if you go backwards, you're raising a power to another power here. You multiply the powers to get to 2x, so I just went backwards. But now notice that we have a 5x here and a 5x here. This 5x is squared, and this 5x is not squared, and we have no 5x term here. So believe it or not, that's a quadratic. I'm going to let y equal, well, maybe I'll just put a little squiggly circle around it. I'm going to let y equal 5 to the x power. And now I'm going to rewrite that equation, but I'm going to plug in y instead of 5 to the x power. So I don't really need the parentheses, so I'm going to get rid of those parentheses. And you don't have to write that extra step with the parentheses. You can just plug y in. And now you can see that this is just a quadratic equation, and quadratic equations require special methods to solve. You can use the quadratic formula, or you can factor. So let's see if this can be factored. What two numbers multiply to 3? Two numbers multiply together to get 3, but they add to get negative 4. if you multiply two numbers, you get positive 3. But if you add those same two numbers, you get negative 4. If you said negative 3 and negative 1, you're correct. So what this tells us is that y can be 3 to make this equation work, or y can be 1. Now, it's very common for students to stop at that point and think that they've solved the problem. We haven't solved the problem. We're not looking for y. We're looking for x. So we have to go back up here where we said that y is equal to 5x. And now we have to plug in, or excuse me, not 5x. 5x is this. I'm not talking about 5x. 5 to the x power. So y is equal to 5 to the x power. So you see that down there. I'm going to plug in for this equation too. Now this equation is very easy to solve. You can probably see what the answer is without even really going any further, but let's change 1 to 5 to the 0 power. That is rule number 7, which tells us that obviously x is equal to 0. If the bases are the same and the exponential expressions are equal, then the exponents must be equal. Now over here, we can't do that. We can't solve that. It takes advanced mathematics. But we still need to know what to tell the calculator. And we're going to tell the calculator log base 5 of 3, log base 5 of 3. That's just the notation that we use to tell the calculator what to do. It's called log base 5 of 3. So now we need to use our calculator. So you should be using a Texas Instruments or Hewlett-Packard or some sort of graphing calculator. But if you're using your iPhone, you're going to enter 3 and then the second button at the upper left, and then log base y right in the middle, and then 5, and then equals. So the answer is going to be approximately 0.6826, because up here it says round to the nearest 10,000th. So remember, we start at 10th, 100th, thousandths, 10,000ths. So if you got that right, excellent. Okay, so now we're going to this problem here, number 14. Now we're just going to simplify. So try number 14. When you come back, we'll do it together. All right, we're back. So we're going to use exponent rule number 1 to combine these a's. We'll just add the exponents and we get a to the 7th power. Then we're going to use exponent rule number 3 when you have a product raised to some power that's equal to the first number in the product raised to that power times the second number in the product raised to that same power. Now we're going to use exponent rule number 5 to multiply the exponents because we're raising a power to another power. Now we're going to use exponent rule number 8 to bring those negative powers down. Again, negative powers have no direct meaning. You have to translate. A to the negative 14 means 1 over a to the positive 14. B to the negative 4 equals 1 over b to the positive 4. So if you got that right, excellent. Okay. on to number 15. Go ahead and try number 15. When you come back, we'll do it together. Okay, we're back, so we need to isolate the exponential expression. This is an exponential equation. It's not isolated because the 8 and the 3 are next to the yellow exponential expression. So we need to get rid of the 8 and the 3, or put it on the other side. So I'm going to add 8 to both sides, and I get 375. You don't have to show both of these steps, but I'm just doing it so you can see exactly what's going on here. Again, when you take the test, you can do both these steps at the same time in your head if you want to. You don't have to, but now I'm going to divide both sides by 3, and I get 125 on the right side of the equation, and 5 to the 2x squared minus x on the left side. And 125 is the same thing as 5 to the third power. And these exponential expressions are equal to each other, and the bases are the same, which means that the exponents must be equal. So this is a special equation, and it has special methods to solve. It's a quadratic, but we cannot use those methods unless we put the quadratic in standard form. So to do that, I'm going to put the 3 on the other side of the equation, and you could put everything on the right side of the equation, but we would prefer a negative coefficient, or excuse me, a positive. We prefer a positive coefficient on the x squared term. So now I'm going to try to factor. I don't know if we can factor or not, but let's try. So what two numbers multiply to 2? Well, that's 2 and 1, obviously. But because it's 2x squared, we have to put 2x and x. What two numbers multiply to negative 3? They're not going to add up to negative 1 because the 2 complicates things. But the numbers will always multiply to negative 3. So I'm going to try negative 3 and positive 1. Now we have to test this to make sure that it works. We have to multiply this back to see if we get to this expression here. So we're going to do FOIL. 2x times x is 2x squared. That's f of FOIL. 2x times negative 3 is negative 6x. That's O of FOIL. And 1 times x, that's I of FOIL. And 1 times negative 3, that's L of FOIL. Combine those and you get negative 5x. So that didn't work because we don't want negative 5x. We want negative 1x. So we have to take 3 and 1 and switch them. Okay, now let's do FOIL again. 2x times x is 2x squared. 2x times negative 1 is negative 2x. And 3 times x is 3x. And 3 times negative 1 is negative 3. Now if we combine these inner terms, we get x. But we're not looking for x. We're looking for negative x. But that's okay because we got this right number. It's just the wrong sign. So now we go to this sign here and we change it to a positive, and we go to this sign here and change it to a negative, and that will definitely give us the right factorization. So why did we do all that? The reason we did it is because now we can see the solutions to this complicated equation. We know that 2x minus 3 must be 0 in order for that equation to work, or x plus 1 must be 0. Because if this is 0 here, you multiply by the purple and you get 0. If the purple is 0, you multiply it by the yellow and you get 0. So those are just those equations are going to give us the solutions which make the equation work. So now we're going to solve, and we get x is equal to 3/2. And over here we get x is equal to -1. So that's an exponential equation, which means there's not going to be any extraneous solutions that you have to worry about. So there you go. Those are the solutions. If you got those right, excellent. Good job. Okay, on to number 16. Go ahead and try number 16. When you come back, we'll do it together. All right, we're back. This is the variation of exponent rule number 8. If you have a negative exponent and your expression is in the denominator, you can make it go up into the numerator and it turns to a positive exponent. The square root of 216, that's the same thing as 216 to the 1/2 power. Why is that? Because 2 is the index here. So that is exponent rule number 9. Now we're stuck. We can't do anything unless we get the same base on both sides. So I'm going to change 36 to 6 squared, and I'm going to change 216 to 6 cubed. And then I'm going to use exponent rule number 5. And I get 6 to the 2x is equal to 6 to the 3/2. So the bases are the same, so that means the exponents have to be the same. Now I'm going to divide both sides by 2, and we get x is equal to 3/4. Now if you had problems dividing both sides by 2, a fraction divided by a whole number, that's just basic math. So you can go online and review that if you need to, but this is intermediate algebra, so that's really something that you need to figure out on your own and really solidify that in your mind if you haven't already done that. Okay, so on to number 17. Try number 17. When you come back, we'll do it together. Okay, we're back. So log base k of 20 is equal to log base k of 4 times 5. So all I did was just change 20 to 4 times 5. Now I'm going to use logarithm property 5 to separate into 2 logarithms. And the reason I did that is because now we have an approximation for log base k of 4, and we have an approximation for log base k of 5. The problem is asking us to approximate the answer. So I'm going to write squiggly lines. Log base k of 4 is approximately 1.26, and log base k of 5 is equal to 1.46. Combine those and you get 2.72. And you don't really need a calculator for that, but I guess you can use it if you want to. If you got that answer, good job. Try number 18. And when you come back, we'll do it together. All right, we're back. So we need to isolate the logarithmic expression. So we're going to subtract 4 from both sides. And again, you can do these first 2 steps in your head and just write the result after your math if you want to. You don't have to show this step that I'm showing here. Now multiply both sides by 4, and we get 4 is equal to log base 2 of 3x minus 5. Now we've isolated the logarithm. So now we need to convert to the exponential form to proceed solving this logarithmic equation. the most important thing, again, when working with logarithms is knowing how to translate back and forth between the logarithmic form of an equation and the exponential form. Remember, the base is always that small number next to the logarithm. The exponent is always what the logarithm is equal to. And whatever's inside the log function, that goes on the other side of the equation. So 2 to the 4th power is 16. And solving this equation, add 5 to both sides, divide both sides by 3. And we get x is equal to 7. So if you got that answer, excellent. Okay, go ahead and attempt number 19. And when you come back, we'll do it together. All right, we're back. So we have a lot of logarithms over here, and it would be very useful to us if we could combine all those logarithms into one. So I'm going to use logarithm property 6 to combine these first two logarithms. When you're subtracting, you combine to one logarithm, and inside the logarithm you have the quotient of the first expression in the first logarithm and the expression in the second logarithm. And then we still have plus log base 4 of x. Now I'm going to use logarithm property 5 because we're adding logarithms. Here we were subtracting logarithms, so we combined them by dividing. And here we're adding logarithms, so we're going to combine them by multiplying. So we have log base 4 of 7/6 times x. And now, again, we need to translate from a logarithmic equation to an exponential equation. So the base is 4. It's always that little number there. And the exponent is always what the logarithm is equal to, so 0. And whatever's inside the log function goes on the other side. Now, exponent rule number 7 tells us that anything raised to the 0 power is 1. So now we just multiply. There's a lot of different ways to do this, but we can just multiply both sides by 6, then divide both sides by 7. We could also do it in one step by multiplying both sides by 6/7. But however you get to that answer, that is the answer. So if you got that one right, excellent. If you didn't get it right, that's okay. Just go back and figure out what you did wrong. All right, on to number 20. Says write your answer as an exact expression. So we have a logarithmic equation, but it's too complicated. So what we're going to do is combine these logarithms. So we have log base 5 of x minus 7 times x is equal to 1. That's logarithm property 5. Then we're going to use the distribution property to multiply x minus 7 times x. And then we're going to translate that logarithmic equation into an exponential equation. So the base is always that small number next to the g on the logarithm. And the exponent is always what the logarithm is equal to. And what's in a logarithmic function always goes on the other side of the equation. Then we're going to use exponent rule number 6. 5 to the first power is just 5. You don't really have to write that step if you don't want to. And now we have to recognize this as a special equation. It's a quadratic equation because there's an x squared term and an x term and a term without an x. So because this is a special equation, we have to use special methods to solve it. But we can't use those methods because we have to first put it in standard form, or else we're not going to know how to use the methods correctly. So we have to put the 5 on the other side. Now we're ready to use our methods. If you try to factor, like we did in previous problems, you're going to find that there are no two easy numbers that you can multiply to get to -5 and add up to get to -7. It's just not going to work. So what that means is we have to use the quadratic formula. So that's the really big, scary formula that we learned in previous parts of this course. So now we're going to plug in. -7 is b. A is 1, and C is -5. And again, A is 1. Okay. So we have a double negative there. -7 is just +7. And be aware, use parentheses in the yellow part there. We need parentheses when you're squaring a negative number. If you just write -7 squared like this, that's not correct, because that's equal to -49. This yellow expression here is not equal to -49. That's equal to +49. That's the right answer, +49, not -49. So we have 49, and then -4 times 1 times -5 is going to be +20. And 2 times 1, of course, is 2. And then we have x is equal to 7 plus or minus √69 over 2. So there are two solutions, two possible solutions. We need to make sure that the solutions actually work, that there's no extraneous solutions. So one solution is 7 plus √69 over 2. Another solution could be 7 minus √69 over 2. Now, you could use a calculator if you want to, but we know that √69 is very close to √64. Let's pretend that this purple is √64, then that purple would be 8. And 7 minus 8 would be -1, divided by 2 is -1/2. The problem with that is if you go to the original equation and plug in a -1/2 here, you get a negative inside the log function, and that's not allowed. So we just showed that this is not equal to that, and you know, √69 is a little bit bigger than √64, so it would actually be an even smaller negative number. So we know that's not a solution. Now this is going to be positive, but we still don't know if that's going to be extraneous, because if you plug it in here and you subtract 7 and get a negative number, well, that's still not going to work. You cannot have a negative number in any one of these red areas there. So let's pretend that this is √64. You get 8. 8 plus 7 is 15. 15 divided by 2 is 7.5. 7.5 is bigger than 7. So when you subtract, you're going to get a positive number. And of course, when you plug in 7.5 here, you're going to get a positive number. And √69 is bigger than √64. So it's definitely going to work. So that is actually a solution. And we don't have to, find a decimal form. It doesn't say to find a decimal form, so we can just leave it like that. So that was kind of a more challenging problem there. If you got that right, excellent. Okay. On to number 21. Go ahead and try number 21, and when you come back, we'll do it together. All right, we're back. So the logarithm is already isolated. So we just need to translate to an exponential equation so we can figure out what x is. Remember, the base is always that little number there. In this case, it's an expression. The exponent is always what the logarithm is equal to. And whatever's inside the log function goes on the other side of the equation, as we said many times already today, taking this practice exam. So now we need to do what's called expanding this expression. What that means is that we're going to multiply x minus 2 by itself. That's what raising to the second power means. So we're going to use FOIL. X times x is x squared. X times negative 2 is negative 2x. And negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Now we can combine like terms, and we get x squared minus 4x plus 4. And you could go straight from here to there. I don't require you to show these steps. I'm just doing that for your benefit. Okay, so now we can subtract x squared from both sides, and we get 5x squared on the left side, or the right side. And we're going to add 4x to both sides, and we get 18x on the right side. And we're going to subtract 4 from both sides, and we get 9. On the left side, we're going to be 0. So the reason that I did that is I recognize this as a quadratic equation. It sure doesn't look like a quadratic equation. But I can combine these terms on the right side of the equation. I can combine these terms on the right side of the equation. And I can combine these terms on the right side of the equation. So that's what I did. This is a special equation, a quadratic equation, so it requires special methods to solve. And we can only use those methods if we put the equation in standard form. So now it's in standard form, and I think we can actually factor this. What two numbers multiply to 5? Well, that's 5 and 1. What two numbers multiply to 9? Well, it's either going to be 1 times 9 or 3 times 3. I'm going to try 3 and 3. Now we FOIL back out. F of FOIL is 5x times x. 5x times 3 is 15x. 3 times x is 3x. And 3 times 3 is 9. Add the inner terms together and we get 18x plus 9, so it looks like I got lucky. I just chose those numbers randomly. I chose 3 and 3 rather than 1 and 9, and I got lucky. 3 times 3 works. Okay, so what this does is it tells us that to make this equation work, we need 5x plus 3 to be 0. Or we need x plus 3 to be 0, which means that x is equal to negative 3, or x is equal to negative 3/5. but we have a big problem. We have a very, very big problem. The problem is, if you plug in either of these answers back into this equation, the base is going to be negative in both cases. This base here cannot be negative because the logarithm would be undefined. Now, I don't know what's going to happen when we plug in those numbers to here. We might get a negative number, we might not, but it really doesn't matter. The base can't be negative, so we know that there's no solution. So we did all that work just to find out that there's no solution. But you will still receive full credit if you show your work and mention that there is no solution. So sometimes that happens. If you got that answer right, excellent. Good. Okay, let's go on to number 22. Go ahead and try number 22, and when you come back, we'll do it together. Okay, we're back. So this equation is too complicated. So we're going to combine these logarithms on the left side of the equation using logarithm property 6. The problem is we can't do that because this 2 is in front of the logarithm. So I'm going to use logarithm property 7 to take that 2 and throw it up into the exponent. I threw it up into the exponent here. It went from here all the way to there. Now, when you do this, make sure that the 2 is the power of both the 3 and the x. You need parentheses. A lot of students, what they would do is they would throw this 2 up here, but they would write log base 8 of 3x squared like that. That's not correct because the x is raised to the second power, but the 3 is not. So just be aware of that. Be sure that you're using logarithm property 7 properly. So that's equal to, and we're going to do the same thing. We're going to use logarithm property 7 over here, so we get 5 squared. We took this 2 and threw it up into the exponent. Again, that's perfectly legal. That's a logarithm property that we can use. Now we're going to use logarithm property 6 to combine these logarithms. The logarithms are subtracted, so we're dividing 3 over 3x squared, and we're going to need brackets because there's quite a few things in the logarithm there. And we can go ahead and simplify. 5 to the second power is 25. Okay. So now we have two logarithms that are equal to each other. Furthermore, the logarithms have the same base. So what that means is that the inner parts of the logarithms must be equal, and we can just get rid of the logarithms. So we have 3 over 3x squared equals 25. So this equation is it's not hard to solve, but a lot of students, to be honest with you, have some trouble. The first problem that they have is they try to divide these. They try to cancel those out. Well, you can't do that. You got to square 3x first. 3x times 3x is 9x squared. Now we can simplify that fraction. 3 over 9 becomes 1 over 3. It just makes the numbers easier for us. And a lot of different ways to solve this. We could multiply both sides of the equation by 3x squared, or we could just flip both sides of the equation. We can flip this so we get 3x squared over 1, and you can consider the 25 to be over 1 and flip it, you get 1 over 25. That's perfectly fine. You can do that. but we can also just multiply both sides by 3x squared. It cancels this fraction out, and we get 1 is equal to 75x squared. 25 times 3x squared is 75x squared. Then we can divide both sides by 75, and we almost have our answer. We just have to square root. And remember, whenever you square root both sides of an equation, you always have to write a plus or minus symbol. That's probably the #1 mistake that students make in intermediate algebra, is they forget to write a plus or minus symbol. Now, we can't have a negative number as one of our answers, because if you plug in a negative here, you get a negative inside the logarithm. That's not allowed. So that means we can just get rid of the negative, and we can say that x is equal to positive 1 over root 1 over 75, square root 1 over 75. Now, I don't really care that much if you change the form of this at this point. Really, the most important part of this problem is that you find this. But technically, you should be aware that teachers are going to make you rationalize the denominator. So that's going to be equal to root 1 over root 75. Root 1 is just 1. And 75 is 25 times 3. I'm factoring this 75 to 25 times 3. 25 comes out because it's a perfect square, and the 3 stays in. Then I can multiply both sides of that fraction by root 3 to rationalize the denominator. And I get 5 times 3, which is root 3 over 15. Now, I'm not showing every single step of that, but the reason we're not showing every step is because we already showed how to do that in the previous parts of this course. If you need to review, you can go back and look at that stuff in the previous parts of the course, but you can't really show every single step when you get up into upper mathematics, because it would just be too tedious. So I am showing you some steps, but not all of them. But really, again, the most important thing is that you get to this point. I would give you 100% credit if you get to that point. Now, we probably need to mention that there's an extraneous solution. So I'm going to go ahead and do that. So one possible solution is x is equal to negative root 1 over 75, but I'm going to say not equal to. And another solution, of course, is x is equal to positive root 1 over 75. Then I'm going to go up here. It's so crucial that we organize our work properly. Remember that. And I'm going to show all of the steps. So sorry, I should have done this as we were going through the problem, because we do have to show extraneous solutions. Okay, so root 3 over 15. If you got that answer, excellent, good job. Okay, on to number 23. Go ahead and attempt number 23. When you come back, we'll do it together. Okay, we're back. I'm going to multiply both sides by 1 plus log base 7 of x. And the reason I did that is because it gets rid of the fraction on the left side of the equation. If I multiply both sides of the equation by 1 plus log base 7 of x, it's going to cancel out that red part. And on this side, we're going to just multiply that by 3. So now I'm going to use distribution. So we get 3 plus 3 log base 7 of x is equal to log base 7 of x plus 5. Now I'm going to take this step by step. I'm going to subtract log base 7 of x from both sides of the equation. Then I get 2 log base 7 of x. Because we subtract it from this side, that disappears. if you subtract it from this side, then 3 log base 7 of x's minus 1 log base 7 of x is 2 log base 7 of x. Then I'm going to subtract 3 from both sides of the equation. Then I'm going to divide both sides by 2. So the whole purpose of what we're doing here is to simplify the equation. And as you can see, this equation down here is much simpler than the equation we started out with. We've combined all the logarithms and we've isolated the logarithm. So now, remember, the most important thing to know when it comes to logarithmic equations and logarithms in general is that you need to know how to convert back and forth between the logarithmic form of an equation and the exponential form. The base is always that little number there. The exponent is always what the logarithm is equal to. And whatever's in the log function goes on the other side of the equation. Now, exponent rule 6 tells us that something raised to the first power is just whatever that number is. And there you go. So if you got that answer, perfect. Good job. We don't have any extraneous solutions when it comes to that problem because plug 7 back in and you get positive numbers in the logarithms. Remember, you can't have any negative numbers in logarithms. So now let's go to number 24. We're just going to simplify this expression. So simplify number 24, and when you come back, we'll do it together. Okay, we're back. So we first need to use exponent rule number 3. So we get 3 to the second power times x to the second power times y to the negative 4th to the second power. And we're going to do the same thing with the denominator of this fraction. We have x to the second power raised to the negative 1 times y to the 5th power raised to the negative 1. And then we're going to use exponent rule 7. Y to the 0 power is just 1. So now we're going to use exponent rule number 5 on these expressions here. 3 to the second power is 9. We can get rid of the dots. And we get y to the negative 8. Again, that's exponent rule number 5. X to the negative 2 and y to the negative 5. Again, these are all exponent rule 5 situations. So then we're going to use exponent rule 4, which tells us if you have a fraction raised to some power, then you raise the numerator to that power and divide by the denominator raised to that power. Now we're going to use exponent rule number 2 to combine the x's. We're dividing the powers. So 2 minus negative 2 is 4. So because it's positive 4, we're going to, we're always going to write in the numerator until, if we get negatives, we can always bring them down. Negative 8 minus negative 5 is -3. And we'll deal with the negative exponent later, as I said. Then we're going to use exponent rule number 5. And we get x to the -10. And exponent rule number 3. And then we're going to use exponent rule number 1 to combine these x's. So we get 9, x to the -6th, y to the -3rd. Over 4, 2 squared is 4, and we're going to use exponent rule number 5 again here. So we get b to the 12th. And we're almost done. We just have to get rid of these negative exponents. So that just means that we're going to bring those expressions down into the denominator and change the exponent to a positive number. And there we go. So if you got that one right, excellent. Go ahead and try number 25, and when you come back, we'll do it together. Okay, we're back. So the order of operations tells us to move left to right when we are multiplying and dividing. So that just means you have to start with the left operation, whatever that may be, multiplication or division. In this case, it's multiplication. So I'm going to multiply those two fractions, so we get 5x to the 8 over x to the 6 times y. And again, you can skip some of these steps, but I'm showing more than I really need to, just so we can explain what's happening here. So now I'm going to use exponent rule 2. We're dividing powers, so we subtract the exponents, and we get 5 x to the 2nd power over y. And then I'm going to change to multiplication and flip the fraction. That's just how you divide fractions. And now we're going to multiply the fractions. When you multiply fractions, you multiply the numerators. So we get 10 x squared times y to the -1st power over y times b, and all that is still raised to the 2nd power. And now we're going to use exponent rule number 2 to combine these y's. And we're also going to use exponent rule number 6 because y is the same thing as y to the 1st power. So -1 minus 1 is -2. So we get 10 x squared y to the -2 power over b, all to the 2nd power. And now we're going to use exponent rule number 4, which tells us if you have some fraction raised to a power, you raise the numerator to that power and divide that by the denominator raised to that power. And now we're going to use exponent rule number 3. So we have 10 squared times x squared squared. And you can use dots. You don't really need to use dots. Sometimes they're useful, but most of the time you don't really have to use dots. times y to the negative 2 power squared. That's all over b squared, so 10 squared is 100. And we're going to use exponent rule 5 to get x to the 4th and y to the negative 4th all over b squared. But remember, we're not allowed to have negative exponents in our final answer. So we're going to move that negative down into the denominator. So our final answer is 100 x to the 4th over y to the 4th b squared. And there you go. So if you got that answer, excellent. So that was the class today. If you'd like to take screenshots of the practice test that we just completed to help you study for the test, go ahead and do that now. This is screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5 and number 6. Now don't go before you get your homework. Your homework is a practice test. So here's screenshot number 1 of the practice test for homework. And screenshot number 2. And number 3. And number 4. And number 5. And number 6. But don't go before you get the answers. Remember, it's not enough to just attempt the practice test. You must do it correctly, so make sure that you got all the right answers. Every time you do a problem, you need to check the answer. If you don't check the answer, then you just wasted all of your time doing that problem. If you got the answer wrong, go back and do it correctly. So here's all the answers. So go ahead and get that homework done. Get the practice test done for homework, and I'll look forward to seeing you in the next class.